Okay, next one, example 12. A car with weight 15,000 Newton is being towed up at 20 degrees slope at constant velocity. Friction is negligible. The tow rope is rated 600 Newton maximum tension. Will it break? Okay, so now we are given a diagram here where you can see there is a car connected with a rope. Okay, so we have the mass of the car. Okay, it's not the mass, it's the weight of the car. 15,000 Newton. And then given the angle 20 degree here. And then it is given, it is moved with constant velocity. It is moving with constant velocity. Okay, friction is negligible, meaning that we don't have the friction force here. And then given here, the maximum tension of this rope is 600 Newton. So, maximum tension, 600 Newton. And then it asks, will it break? Okay, adakah tali ni akan putus apabila dia tarik kereta ni? Okay, so how do we determine whether dia akan putus atau tidak? Okay, macam mana kita mau cari ni? Kita akan bermaksud dekat sini, we need to find the value for the tension here. Okay, so let's list down here. We have the weight. The weight is 15,000 Newton. Then we have angle, 20 degree. Okay, so first of all, let's identify the forces. Okay, macam biasa, identify dahulu. Kita tahu dia ada weight force going downward. And then since dia adalah dekat surface, okay, we have the normal force. And then kita ada tension force going here, which is away from the, it must be away from the object. Okay, and then masukkan dalam free body here ke bawah W. Sini adalah ke sini adalah normal force ni. This one, this is y axis, this is x axis. So going here is the T. And then angle. Okay, angle tu adalah dekat mana angle tu? Sini kah sini? Okay, dia dekat sini. Nanti kamu double check. Dia memang akan dapat angle tu di sini. Okay, sebab I already explained how to locate the angle in the previous video. So you can try it on your own. Okay, now because we only want to find value for T, di mana value for T ni hanya ada di x-axis saja. So we don't need to resolve into x and y component. Okay, so hanya x component sahaja yang kita kena resolve. So x component, di mana x component yang kita ada T dan wx. Okay, T and wx. So kita kena resolve here wx, di mana wx ni adalah sama dengan w sin theta. Okay, w sin theta. So masukkan T minus, okay, dia ke kiri kan? Remember, it will be minus w sin theta equal to 0. T is equal to W sin theta. So W kita ada value dia. Masukkan saja sin, and then theta is 20 degree. So kamu tekan calculator and then you will get 5130.3 Newton. So if you compare this one and this one, okay, the tension here doesn't exceed the value here. So bermaksud the T is less than T max, which is T is less than 6,000 Newton. So the rope will not break. Okay, now the last example for this subtopic, Example 13. A window washer pushes his scrub brush up a vertical window at constant velocity by applying a force as shown in figure. The brush weighs 10 Newton and the coefficient of kinetic friction is mu k 0.125. Calculate the magnitude of the force and the normal force exerted by the window on the brush. Okay, so as you can see in the figure here, we have a window here and then this is the brush. So basically this is our object. So this brush is pushed up, okay, push up here, where the angle between the, apa nama dia ni, pemegang dia ni kan, is 50 degree. Okay, so now, this is our object. We want to find the force, value F here, and then the normal force. And we are given the weight of the brush is 10 Newton and then the coefficient. So we have the weight 10 Newton. Okay, this one is weight. Kalau dia Newton, dia adalah weight. Kalau dia kg ataupun gram, dia adalah mass. And then coefficient of the friction 0.125. So we know, maksudnya dekat sini dia akan ada friction, kinetic friction. Okay, so first thing, let's identify the forces. So obviously dia akan ada weight going downward, and then since it is a window, it is a surface, it will have normal force. And then dia ada external force, dan satu lagi dia akan ada kinetic friction. So kinetic friction, okay, kalau brush ni dia ditolak ke atas, maksudnya motion dia ke atas macam ni kan. So kinetic friction tu akan ke bawah. Okay, it will be going downward. Okay, sebab dia always opposite direction with the motion. Motion dia ke atas. So dia punya because it wants to prevent the motion, so it will be going on the opposite direction. Okay, so now lukis FBD. Start with a dot, and then ke bawah kita ada weight. Pergi kiri kita ada normal force, and also ke bawah ada FK, friction, and then external force is going this way. And then we have an angle here. Okay, if we see here, kita panjangkan benda ni. Angle tu adalah dekat sini kan, 50 degree. So the angle here will be equal to the angle here, which will be equal to the angle here. Okay, boleh nampak kat tu? Angle dekat sini akan jadi angle dekat sini, sama dengan angle di sini. Which is angle dekat sini adalah sama dengan angle di sini. Okay, remember again what you learn in maths sekolah menengah dahulu. Okay, so now lepas kita sudah melukis FBD, masukkan dalam jadual. So value yang kita ada dekat sini is W. So W ada, N tiada. This one we need to find. FK, do we have FK? FK, actually, do we have FK? We don't have FK. Okay, so meaning that FK, you need to find it as well. Okay, we have this one. We don't have normal. So masukkan dahulu F and FKW. So F ni, okay, buat macam biasa lah kan. F cos 50 and then F sin 50. So N to the left, negative. Y component kosong. FK pula dekat Y axis. So X component kosong, it's going downward. It is negative. This one. Terus masukkan negative 0.125. And N is the normal force. W kosong, this one, negative 10. So the sum will be equal to 0. So what we want to find here is 2 unknown. Okay, 2 unknown meaning that 2 equation. So keluarkan equation macam biasa. F cos 50 minus n equal to 0. So F will be equal to, sorry, bukan F. So F cos 50 will be equal to n. That's the first equation. Second one, F sin 50 minus this one and minus 10 equal to 0. And then this one is the second equation. So n ni boleh masukkan ke sini. This one kamu substitute. So F is equal to 14.58 Newton. Okay, so this one soalan A. Soalan B, we want to find the value for n. So just masukkan using the first equation. N is equal to 14.58 F here cos 50. So sama dengan 9.37 Newton. Okay. So kalau soalan minta what is the value for FK, kamu boleh masukkanlah value n ke dalam ni and then you will get the FK. Tu kalau soalan minta lah extra question. Okay, that's all for example 13.